Okay, in this video we're going to talk a little bit about what makes the nucleus stable, and if it's unstable, what does it do to try to get stable. And we're going to focus on something called transmutation, which is the conversion of one element into another element. So when we're talking about stability, if you remember from the last video, it's all about the proton to neutron ratio. Well, there's something called the band of stability. And basically in this graph right here, the band of stability, it shows that optimum proton to neutron ratio depending on how big the atom is. So small atoms really want a 1-to-1 proton to neutron ratio. And as they get bigger and bigger, you can see they tend more towards a 1.5-to-1 neutron to proton ratio. So it really is okay in those big atoms to have more neutrons than protons and still be stable. Now, if something is radioactive, it falls outside of the band of stability. And the band of stability actually ends at lead-208. So any element with an atomic number greater than 82 is radioactive. They're just too big in the nucleus to be stable. So what happens to try to become stable? Well, they go through radioactive decay, meaning they give off alpha particles or beta particles. So let's look at our first example. If an atom has too many neutrons compared to protons, it's going to give off a beta particle. And what happens is a neutron is converted into a proton, and then the beta particle is given off. So here you can see we have carbon-14. It gives off a beta particle, and it went from having 6 protons to 7. But the total mass number stayed the same. So it converted a neutron into a proton to get back to that stable ratio. And then elements can also undergo alpha decay. If they really are just too big, they have too many protons and neutrons in their nucleus, then they'll give off alpha particles, which will make both the proton and neutron number reduced. So here we have polonium-210. And you can see it gives off an alpha particle, which is 2 protons and 2 neutrons, and it becomes lead-206. So it's just a little bit smaller and it's trying to be stable. Okay, now we want to look at how we can write all of this out as a nuclear equation and figure out what's left over when something goes through alpha or beta decay. So here's our example. It says, in plutonium-238 atom undergoes alpha decay, write a balanced equation for this decay. So you can see here we have plutonium-238, okay, it's number 94, that's what makes it plutonium, and we're going to try and figure out what is left over when it loses an alpha particle. So the way we do this is we look at the protons first. So we start with 94 protons, we lose 2, so we will have 92 protons left over. We have 238 as our mass number. We lose 4, so that goes down to 234. Now, how do we know what the symbol is? Well, 92 protons, if we look at the periodic table, we know that the element with 92 protons is uranium. So plutonium turns into uranium when it gives off an alpha particle. So that's how we're going to write these nuclear equations and balance them, is we're going to pay attention to those mass numbers and to the atomic numbers and make sure that they're balanced on both sides. Okay,